Hi, this is video number 2 in the continuing series on completing the duct design calculations for residential air system design. In this video we will look at completing part E, which is the inlet flow rates. We start with the basement. Now there is a rule that says that you cannot return more than 50% of the air that you deliver to the basement. So however, our calculation requires 25 CFM to the basement and 164 CFM heating to the basement. But since the 50% rule is in effect, that means we can only return 82% heating and 82 CFM heating and 12 CFM heating. On the first floor, we take the total sum of the first floor airflow rate for heating, which is 294, and we add the balance of the basement airflow. So we would add 82 CFM to 294 CFM, and that gives us 376 CFM for heating, and we take the total cooling airflow rate of the first floor, which is 354 CFM, plus 12 CFM to give us 366 CFM cooling requirement for the first floor. On the second floor, we have a total requirement of 254 CFM for heating and 330 CFM for cooling. Now, to determine the minimum number of openings, and by openings they mean return inlets, we have to look at the individual flow rates from each level. In the basement, this is a pretty small flow rate, and so one return will be sufficient to handle this airflow. On the first floor, we've got as much as 376 CFM. Now you'll notice that we've got two airflow rates, one for heating, one for cooling. And in the case of the first floor, the heating airflow rate is greater than the cooling, so we have to ensure that we design for the heating airflow rate. However, on the second floor, you'll notice that the cooling airflow rate is quite a bit higher than the heating airflow rate. So we have to ensure that we can get enough return air to satisfy the cooling airflow rate. The general rule for establishing the number of return airs would be to take the individual amount and divide it by approximately 120. 120 CFM is generally a good rule for the amount of air that you can get through a 14 by 3.5 plate opening. So if we divide 376 by 120, we get slightly over 3, so 3 will be good enough here. And in the case of the second floor, if we divide 330 by 120, we get slightly under 3, so we would still go with 3 outlets. The actual number of openings we really don't know yet. You've got to go through all the calculations to determine that, and so we would have to come back to this line once we have completed the calculation. The actual CFM per opening is simply the amount of air divided by the number of openings. And so in the case of the first floor, if we're going to go with 3 openings, we would have 125 CFM heating and 123 CFM cooling. And on the second floor, we would have 85 CFM for heating and 110 CFM for cooling. So this gives us a workable air volume per opening.